So I touched on this earlier, but I want to make sure that we have a very clear understanding of when we use the standard normal distribution and when we use the t-distribution. So we're going to take a little bit of time to talk about how we know which one to choose between those two. Because if we don't choose the right distribution, then we're not going to get the right confidence interval. And if you're using the tables, that means you have to know whether you're using the first two tables in the statistical packet for the standard normal distribution, or if you're using the third table for the t-distribution. And if you're using StatCrunch, you have to know whether you pick between z-stats or t-stats, or z-test or t-test. If you're using your calculator, you have to know whether you're going to use inv norm, or invt. So it is important that we're able to tell the difference between these types of problems. So we have seen now several examples of us constructing confidence intervals for the population mean mu. We have seen examples where we have done it when we knew what the population standard deviation was. That's what we were doing in lesson 18. And then we have also seen examples where we did not know what the population standard deviation was, where sigma was unknown. That's what we saw in lesson 19. So now we're going to make sure that we know how to tell the difference between whether we should be using the standard normal distribution, I'm abbreviating some things here, or whether we should be using the t-distribution. Because whichever one we use is going to definitely change our answer. So there's a flow chart down here that summarizes which distribution that you should use. So starting off in the upper left corner, the flow chart starts here. You have to always start off asking yourself, was the population normally distributed, or was the sample size greater than or equal to 30? If the answer to that question is no, you can't use either distribution. You can't use either the standard normal distribution, that says standard norm, nor can you use the t-distribution. If neither the population was normally distributed nor the sample size was greater than or equal to 30, you're not going to be able to form that confidence interval. If the answer to that question is yes, good. That means that you could use either lesson 18 or lesson 19. And that choice depends on whether or not you know the population standard deviation. Is sigma known? If sigma is known, if the answer to that question is yes, you're back in lesson 18, where you will use the standard normal distribution. And if you are using the standard normal distribution, the formula for your error is z sub c, which is the critical value that you find from the standard normal distribution, multiplied by sigma, the population standard deviation, which you do have because you did answer yes to it being known, and you divide by your sample size n. If sigma is not known, if the answer to that question is no, then you are in lesson 19, and you will be using the t-distribution. That blank is kind of long. We don't have anything else to put there. But you will be using the t-distribution, and the formula for the error if you're using the t-distribution is t sub c. Well, I have something to put there now. Multiplied by s divided by the square root of n. And again, you all, just to make sure, like where these things are writing, the t sub c and the s are in the top. So even if you're using a calculator, like those two things are multiplied together in the numerator. You're also using the t-distribution with your degrees of freedom equal to n minus 1. If you do not know that population standard deviation. So I wanted to make this video to make sure that, okay, we've seen examples in lesson 18, we've seen examples in lesson 19. When we get to the point where all the examples are jumbled together, how will we be able to distinguish between whether we're using the standard normal distribution or the t-distribution? And this flowchart will help you with that.